Looking at this simple exercise we saw in the video after the circuit entry. First of all, we learned how to decompose the plant into hydronic modules and then write down pipe lengths in the next table. What we will do here is we will decompose a plant, we will write down pipe lengths, but we will immediately introduce this as a project into HySelect so we know how the entry is done. So let's look at this drawing here. We have a pump and partner valve, and then we have two risers. This could be risers where there are two floors or two parts of the system with a terminal unit. So what we see here is a balancing valve there and a balancing valve there. So we have two hydronic modules. So the HySelect logic will be that this will be the star A. So we'll write it down here on this drawing. So this is our star A, and then here we will have the A1, so the star A.1. Here we will have the star, because this is the second module on this distribution pipe, we will have the star A.2. Here, as this is the first circuit in this, or the first module in this riser, we will have the star A.1.1. We continue with the star A.1.2, so the second circuit of this riser. Here we will have A2 and the first one, so star A.2.2.1. and here we will have the star A.2.2.2. Okay, let's add some information. There is 2000 liters per hour running through this terminal unit with 10 kPa of differential pressure. That is something we know, and it will be same for all the four branches. So let's use this as information to work with. We have a heating installation with standard water. So no additives. Voila. Okay, let's introduce this in HySelect. So we'll start a new project. First of all, we will check if all the parameters are set correctly, and also in the project we need to configure the different tabs in the ribbon so that they are working correctly to our desired values and parameters. So here we will call this exercise 0. We do want the hydraulic circuit calculation to be active, and the freeze hydronic circuit calculation is unchecked. It is a heating plant with standard water, so it is no additive, normal water at 75 degrees, default delta T. It's not given here, so we will leave it at 10. The purpose for the exercise is building the structure. The detailed calculations will come later. So we start by clicking right on the hydraulic network. We click add circuit, and then we start with the first part of the system. This is the pump. So we do have this type of distribution. It is pump with a partner valve. We select this one, click next. Here we don't have any information about the pump, so nothing is mentioned, so we leave this purple box open, and then, as you know, the other white boxes, these will be completed by HySelect after the calculation for flow and differential pressure, or for flow and minimum differential pressure. We click add, and immediately HySelect is creating my second circuit. In my case, this is the A1 here, so this riser, and it is a distribution circuit with a partner valve. So yes, we can continue. What we will do, we will change the naming here. We call it riser 1, and then nothing to be completed, as you know, only the distribution pipe. The distribution pipe is 6 and 6, so a total of 12 meters, remind that you need to complete the supply and the return pipe length, and we leave the end size for what it is here. Click add, and now we are creating the A2, or as you see, the second part of the system. Same hydronic setup, only here we will need to change into riser 2 as a description, and then nothing to be completed here except for the distribution pipe. Distribution pipe is from this connection point to here and from this connection point to there, so we do have 14 meters in this distribution. We click add, and now a third circuit is automatically created. We do not want that because we want to now build onto this hydraulic network. Riser A1, click right, you see the red marking. This is because the information in A1 is now incomplete, so HySelect is unable to complete a full calculation. We click right, and then we click add circuit. Now we do have a terminal unit because these are two terminal units. Let's take the example of fan coil units. But we have a proportional control. We see here the round marking, so it means modulating or proportional control. We take the two-way control circuit, click next. Now we need to complete the information. We call it floor 1, riser 1, and then the flow, what we said, is 2000 liters and a dP of 10 kPa. Voila. The distribution pipe, this is this part, so coming from this connection point to the connection to the circuit, and this pipe length coming here. So we have a total of 2, 3, 4 meters in the distribution pipe. The circuit pipe is 2 plus 2 plus 1 plus 3, so we do have 8 meters in the circuit, 8 meters, and here we could call it fan coil 1. Okay, everything is completed except for the remark. You could add a remark here. We click add. As you know, HySelect will immediately create the second one, so we could simply use this. We change into fan coil 2. The floor is the second floor now for riser 1, so we change the description. The flow rates and the differential pressure is the same. We just need to check the length of the pipes. So here we have 3 plus 3, this is a total of 6 meter distribution pipe, and the circuit pipe is 4, 5, and 4 is 9 meters. Okay, we click add, and now my first riser is ready. So we continue by closing. A11, you see the red marking is now gone because the information is completed. A11 and then A12. Now there are two options to continue creating here, or we start adding a circuit to the A2, but as the information will be quite similar, we could choose to go one level up and then to simply copy what we just created in the A1, go to A2 and click paste in A2. By doing this, we immediately create the same information, or add the same information into this A21. We could check to see if it's correct by clicking those circuits open. So we click them open, and then we could correct the distribution pipe length and the circuit pipe length here. This will be the same, as we said that all terminal units need the same flow, same differential pressure. So this is one way to do it. Let's do it for this one here. We are at the A2 position 1, so this is floor 1 but riser 2. Let's call this one fan coil 3. Voila. And then the distribution pipe, this is this pipe section here, so 2 plus 2 is 4 meters. That is correct. And the circuit pipe, this is the 2 plus 2 plus 1 plus 3. This is the 58 meters, so this is still correct, this is similar. Second option to change is to look here in distribution. Distribution we see 6 meters, this is correct. And then in circuits you see the circuit pipe length for example this second circuit, and this is 9 meters. 4, 6, it is 10, so we need to change to 10 meters there. 10 meters, this is fan coil 4, so let's change the naming to fan coil 4 simply by double clicking into this case here, and then the description is wrong because this is floor 2, riser 2, as you know. Voila, by doing this we completed all the information here. So now as an outcome we see the total flow, which is 8,000 liters, 4 times 2,000 liters. The H min is 42.7 kPa with the pipe sizes and the pipe type we selected before. And then we get a power of 88.2 kilowatts.